Fed up on fed up. Fed up, fed up, fed up, fed up, fed up on fed up. Fed up, fed up.
A great day to my panel and my supervisor, Dr. NORIZAN. I am MITTIRAAN GOPALAKRISHNAN.
I am RENGANATHAN, son of VIJAYAN.
I am RAJINDRIN, and this is our IDP project. Our title is Solar Powered Smart Watering System. So let's move on.
I explain about the coding for our water powered smart watering system. This setting is for capacitor soil, which means our capacitor soil moisture sensor, and water pump using node MCU and multiplexer. Okay, now this is our declaration, ESP826655 everything. This part is our blink and Wi-Fi access point. This is our multiplexer pin connection pin mode to node MCU. So this is everything, our declaration for sensor. And let's say 650 plus means dry, below 650 is moist enough, so we just declare two. So one for 650 plus, second one is for 700 plus, which means dry lah. Then we put here for motor water pump trigger, so relay we fix to D4 and D5. So this is our analog output for 16 channel. So this one is for our IoT concept. It will be send the sensor value at blink system. Otherwise we got, so for in system we got two water pump, so it working alternatively watering the plant. So the first one we choose channel 15, so which means 1111 output. So it's work like if 650 the soil is too dry, which means 650 above, it will be watering the plant, which means water pump will be turned on. So it will be watering for 5 seconds. After 5 seconds, it's already moist enough ready, 650 below, it will be turned off. Then it will be serial print will be detect, our sensor value will be shown and will be sent to our blink system. Similar to our water pump 2, we just choose channel 0, which means 000. The function wise everything different. So that's all, doctor. Now we demonstrate our project.
Solar panel, this is for IDP project. As we can see, this is solar panel. Solar panel is alternative green energy that is being used for a few years, and this is a technology that we are going to implement in our project. And here we can see this is a solar charge controller. As in the solar charge controller, we can see that currently the solar is charging the battery, and this is the output that we need to use for our purposes. But in our project, we will be using this USB port as our output. Then this is a basic simple connection to the battery, and the positive negative terminal is connected back at the solar panel. As shown just now, this is the solar panel connection for our project IDP. This is solar panel, and it's connected to the solar controller. Then it is connected to the battery and it's supplying to our pump. That's all from me. Okay, doctor. Now I will summarize my IDP project simply. Okay, let's see. We're using two capacitor sensor, one node MCU, demultiplexer, two relay, then two water pump. So okay, now simple, just in home, let's say we put capacitor. If it's dry means pump will be turned on. Okay, so if it's moist means pump will be turned off. So when the watering plant only for 5 seconds, if still dry means it will be turned on until 5 seconds. 5 seconds will watering, 5 seconds will be stop, 5 seconds will be watering. So if moist means it will be stopped. So okay, doctor, we demonstrate our IDP project. Okay, let's see now two moisture sensor in condition wet condition, which means enough moisture. So it means in blink connection it will be below 650. So let's see, the water pump will be both will be turned off. So if let's say if the capacitor 1 will dry, so let's see now capacitor 1 will be dry, motor will turn on for 5 seconds. So again, if still dry, it's still on for 5 seconds.
So now let's the blink will be more than 650 for one motor. Okay, we keep, so get capacitor. Okay, now the second capacitor will be dry, so the motor turn on just a bit, so the motor will be turned on for 5 seconds. So it still continue because it's still dry. So when I put in water, it's become moist. So now both will be turned off. Okay, now that's the last try. We took both capacitor, which means both are dry. So both water pump will be turned off alternative for 5 seconds. So in the blink, both will be more than 650, which means it's dry. So now both capacitor sensor will be direct into enough moist sensor. So motor will be turned off both. It will be because of delay. So this will be last turn. Now it will be off. So in blink both will be below 650, which means enough moist. That's all, doctor. This is our connection, everything.
Hello, so today I'm going to explain about the blink app for our project. So yeah, first we can click this, we can put our title here. So we are using Note MCU, it will show here. We can add other Arduino device and we can get our token from here, and this is all not so important for us. Okay, now, so this is the icon we can choose. So I choose button for our motor, 2 button, and gauge for our 2 moisture sensor level, and LCD, and I took notification. So yeah, now our blink is online for our Note MCU. Okay, yeah, it's online now. Okay, let's move on. So this is our moisture value for sensor 1. From here we can observe it is below 650, so it is wet enough, so the motor don't need to run. So this is our second sensor. This is also below 650. From here we can observe the value is almost same from here. So this is our button for motor 1. We can on this one to run our motor from anywhere and around this world. And this is our motor for second motor. And this motor is connected to D4 and this motor is connected to D5. So yeah, that's all from me.